So here is question number 26, everyone. Three charges plus q and minus q places on the circumference of circle of radius small r. The force on charge plus capital Q placed at the center of circle as shown in figure will be what? Where 1 by 4 pi epsilon naught can be written as k. Now see, suppose this is charge number 1, this is charge number 2, this is charge number 3. The forces on this plus q. Charge number 1 will attract, say F1. Charge number 2 repel, say F2. Charge number 3 repel, say F3. Now F1 can be written in the vector form k q q divided by r square plus I cap. Similarly F2 can be written in the vector form k q q divided by r square. Repulsion, the force we can see in the diagram, is in positive x direction, so I cap. Similarly F3 vector k q q upon r square, positive y direction, j cap. Now the total force F will be what? Vector F1 plus F2 plus F3. We have 2kq q upon r square I cap plus kqq upon r square j cap. This is our final answer. Now let us try to find out the options. We can say that option number 2 is perfectly matching. Absolutely correct. Now move on to the next, that is 27 number. So here is question number 27, everyone. The combination of two bar magnets makes 8 oscillation per second in an oscillation magnetometer when like poles are tied together, and 4 oscillation per second when unlike poles are tied together. The ratio of magnetic moment of the magnet will be what? We know very well that the time period t for magnetometer is given by 2 pi under root I upon mbh, horizontal magnetic field or magnetic moment m, I moment of inertia. Here 8 oscillation per second, frequencies are given, so we can write t1 equals to 1 by 8 and t2 equals 1 by 4 second respectively. In case of like poles, the net magnetic moment m will be what? Added m1 plus m2 in the same direction, because so therefore t1 can be written as 2 pi under root I upon m1 plus m2 bh. And similarly, if unlike poles are tied together, the net magnetic moment will be subtracted, m1 minus m2, and therefore time period t2 will be what? 2 pi under root of I upon m1 minus m2 bh. Taking the ratios and squaring them, we will get t1 upon t2 square equals m1 minus m2 upon m1 plus m2. t1 is 1 by 8, t2 is 1 by 4. So solving it gets us 4 square upon 8 square equals m1 minus m2 upon m1 plus m2. Let us solve it further. 1 by 4 we will get as a result, cross multiplying, m1 plus m2 equals 4 times m1 minus 4 times m2. So therefore ultimately we will get the ratio m1 m2 as 5 by 3. Option number 4 is perfectly matching. We can go with this. Option number 4. Now move on to the next, that is 28 number. Here is question number 28, everyone. Let r1 vector equals 4t j cap plus 3t square I cap and r2 vector 3t I cap plus 4t square j cap represent the position of particle 1 and 2 respectively as a function of time t. r1t vector and r2 vector are in meter and t is in sec. The magnitude of relative acceleration of one particle with respect to other at t equal to 2 seconds will be. Now first of all, we know very well relative displacement r relative can be written as r1 vector minus r2 vector, which will be 4t j cap plus 3t square I cap. This is r1 minus 3t I cap plus 4t square j cap. This is r2. Differentiating, we get relative velocity v relative, that is 4j cap plus 6t I cap minus 3 I cap plus 8t j cap. Differentiating once again with respect to t, we get relative acceleration, which is asked in the question. That is 6i minus 8 j cap. So this is relative acceleration in vector form. Magnitude, A relative will be what? Under root 6 square plus 8 square. That is 10 meter per second square. So A relative will be 10 meter per second square. Option number 3, absolutely correct. Move on to the next, that is 29 number. So here is question number 29, everyone. Uniform magnetic field restricted to cylindrical region varies linearly with time as shown in figure. The graph showing the variation of induced electric field E with a distance r from the axis of cylinder will be what? Now, according to the question, the magnetic field B is directly proportional to time. Or we can write this, dB by dt will always be what? Constant. If the point at which we are calculating the induced electric field resides outside this cylindrical structure, it means small r is greater than capital R. For these points, we have flux phi equals to pi r square into B. Induced EMF d phi by dt in magnitude form, we can write pi r square dB by dt. Now, this d phi by dt is induced EMF. Induced EMF is related to induced electric field in accordance with magnitude as E dot dl. Therefore, pi r square dB by dt. E dl will be what? Integration of this closed loop, that is 2 pi r equals to pi r square dB by dt. Now see, pi r square constant, dB by dt constant, 2 constant, pi constant. It means electric field outside will be inversely proportional to r. This is induced electric field outside. Now let's talk about inward point, inside points. For small r less than capital R, in those cases the same thing, we can write E dot, this time 2 pi small r will be what? Flux will be what? Pi small r square, means this much only, into dB by dt. Now r cancel out from here. We can see electric field is directly proportional to r for inward points. So therefore we can plot the graph, induced electric field versus distance from the axis. From axis to the radius, it is directly proportional, and then further it is inversely proportional. So we can go with option number 1, which is absolutely correct. Now move on to the next, that is 30 number. Question number 30, everyone. A coil has an inductance of 0.7 Henry and is joined in series with a resistance of 220 ohm. If an alternating voltage of 220 volt of 50 cycles per second is applied to it, then the phase angle between current and voltage will be what? Now we know very well XL given by omega L. Omega is what? 2 pi into F multiplied by L. Things are given. 2 pi is 22 by 7. Frequency, that is 50 into L, 0.7. When we solve, we get this XL as 220 ohm. R given 220 ohm. Let's draw the impedance triangle. Resistance, inductive reactance XL. This is impedance and this is known as phase difference phi. From here we can write 10 phi equals perpendicular upon base, that is XL upon R. Both are equal, so 1. Therefore we will get the value of phi as pi by 4. Option number 2, absolutely correct. Now move on to the next, that is 31 number.